In every healthy human body, there are two distinctly shaped organs called kidneys. Laying in the upper abdominal cavity, their function is to filter the blood and get rid of the body's waste. The functional unit of the kidney is the nephron, and each kidney is home to millions of nephrons. Each nephron is essentially the same, with 5 key parts. First, you start off with the Bowman's capsule, then you turn into the proximal convoluted tubule, go into the loop of Henle, to the distal convoluted tubule, and lastly, straight into the collecting duct. My name is Kaitlyn Chan, and today we'll be focusing on the loop of Henle for this video. When the blood first enters the kidney, it's rich with nitrogenous waste. As the blood makes its way past the Bowman's capsule, water and other components such as sugar, sodium, and potassium are filtered out and enter the nephron. This new fluid is called the filtrate. After passing through the proximal convoluted tubule, the loop of Henle and the countercurrent multiplier come into play. This component of the nephron is made up of 2 main parts, the descending and ascending limbs. In the descending limb, water can return, and in the ascending limb, water can be reabsorbed. As the filtrate moves down the descending limb, water moves out of the tubule and into the surrounding kidney tissue, the medulla. At the bottom of the loop of Henle, the inner medulla has a molarity of 1200 milliosmoles, creating a hypertonic environment. As the filtrate moves through the ascending limb, sodium chloride moves out and into the medulla. This increase in sodium chloride then helps to promote a positive feedback system to pull more water out of the descending limb. This countercurrent multiplier of the loop of Henle is the process of using energy to create a concentration gradient in order to reabsorb water and create more concentrated urine. Essentially, this system increases the concentration of the solutes, mainly sodium chloride, that are present in the inner medulla of the kidney, which then pulls more water out of the descending limb of the loop of Henle. This process is called countercurrent because it involves the countering movements of the descending and ascending limbs and their interacting flows. The most important part of this system, however, is how the ascending limb is not permeable to water. As the sodium chloride is actively transported out of the filtrate, the ascending limb is impermeable to water in order to prevent it from following the sodium chloride out. This also allows water to leave the descending limb at a higher rate in order to follow the concentration gradient. This feature of the loop of Henle magnifies the effect of the concentration gradients and pulls even more water into the surrounding tissues, leading to higher water retention for the body. Overall, the loop of Henle and the countercurrent multiplier are extremely important processes and parts of normal kidney function. Without the countercurrent multiplier, the body wouldn't be able to retain as much water for so little energy. These processes are important components of the body system and contribute to the maintenance of a healthy body.